Welcome back. In this video, we are going to solve problem 13-13 that is taken from chapter number 13, Buckling of Columns, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. So statement is an A992 steel column has a length of 5 meter and is fixed at both ends. If the cross-sectional area has the dimension shown, determine the critical load. So this is the cross-sectional area that is shown. The length is 100 millimeter. The width is 50 millimeter. Thickness of this column from each side is 10 mm. So you have to find the critical load. Let's start with the solution. As we know that from Euler formula that critical load is equal to pi square E times I divided by LE square, where L is effective length and that can be written as K into L. So pi E I and LE is replaced by K into L. What is K? K is the factor that it is given that both ends are fixed. So we will go toward the books and we will see that for both ends are pin support, what both ends are fixed, sorry. So you can see both end fixed. We have K is equal to 0.5. So K is equal to 0.5 for both ends fixed. Now what is the value of E and yield stress? We will need that. So for that we will go to the end of this book and we will move toward the average mechanical properties. So you can see this is in SI unit. So A992, you have to look at A992 steel. E is 200 gigapascal while yield stress is 345 megapascal. 200 and 345. So 200 gigapascal and 300, sorry, I forget 200 and let me check it again, 345 megapascal. Okay, now you can see you have this E, you have K, you have L as well. You do not have I. So what we will do is that we will find the moment of inertia I for this beam. So if you divide it horizontally as well as vertically, so it is symmetrical about both horizontal and vertical axis. So it will be centroid, so neutral axis will pass through this centroid. So what we will do, we know that moment of inertia for rectangular section is equal to 1/12 BH cube, and you can see this is the hollow section. So what we will do is that we will consider this whole section as solid and then we will subtract the moment of inertia of this empty section. So I will write 1/12, base is 100 millimeter, which is 0.1, and height is 50 millimeter, which is 0.05 whole cube, minus the moment of inertia of this shaded portion. So it will be equal to 1/12. Now this width will be equal to 100 minus 10 from each side, where that will be equal to 80. So width will be 0.08. And what will be the height? So height 50 minus 20, which is 30, and 30 is 0.03 whole cube. So this will be the I value. Now we will calculate it. So 0.1 multiplied by 0.05 whole cube divided by 12 is equal to 0.00001041 minus 0.08 multiplied by 0.03 cube divided by 12 is equal to 0.000018. So I will be equal to now 0.00001041 minus this answer will be equal to 0.000086 1. So we can also move, if you want to move this decimal to this point, so this is 1 2 3 4 5 6, so we can also write this as 0.861 into 10 raised to power minus 6 meter power 4. This is the value of I. Now you have all the values, just plug it in this formula. So we know that P critical is equal to pi square E times I divided by KL whole square. So I pi square E is how much? 200 gigapascal. So 200 into 10 raised to power 9 Pascal, and I is 0.861 into 10 raised to power minus 6 divided by what is K? So K is 0.5. So 0.5 multiplied by length is 5 whole square. Now what we will do is that we will find this, we calculate this critical stress by using calculator, and now we'll put the value 3.1417 square multiplied by 200 multiplied by 10 power 9 multiply by 0.861 into 10 power minus 6, that is equal to 1699662.204 divided by the second term is 0.5 multiplied by 5 is this one, and its square will be equal to 6.25. Now 1699,662.024 divided by 6.25 will give you 271,945.92 Newton, and you can see that P critical, in if you divide it by 1000, that will be equal to 271.94 kilonewton, and if you round it off, so P critical will be equal to 272 kilonewton. So this is the maximum axial load, compressive load that can be applied in this column. Now we will check validity of Euler formula, whether it is exceeding yield stress or not. So we know that if your critical stress is less than the yield stress, so it will be okay. So what is critical stress? Critical stress is equal to critical load divided by the area, that should be less than the yield stress. So what is the area of this? So you can see again, this is hollow rectangular section. So we will take the first whole, that is 0.1 multiplied by 0.05 minus the area of the hollow section, which is 0.08 multiplied by 0.03. Okay, calculating it. So 0.1 multiplied by 0.05 multiplied by 0.08 multiplied by 0.03, that will be equal to 0.000012 square inch. Or you can also write A as 0.0, let me check it, 0.1 multiplied by 0.05 minus 0. Okay, I have written multiply instead of minus, so this is minus. So that is, let me correct it, it is 0.0026. 0.0026 square meter. So you can also write it as 2.6 into 10 raised to power minus 3 square meter. Now you have to plug this area over here. So P critical is 272 kilonewton divided by area, which is 2.6 into 10 raised to power minus 3, that should be less than the yield stress. Now 272 divided by this area which was 0.0026 will give you 104,615. 104,615 kilopascal, that is less than yield stress. Say again, if you divide 1.615 k pascal. Okay, now if you multiply and divide it by 10 raised to power 3, so what we will get is 10461 into 10 raised to power 3 kilopascal divided by 10 raised to power 3, that should be less than yield stress, and this term will give you 104.615, and 10 raised to power 3 kilo will be equal to megapascal is less than the yield stress. So it means that 104.615 megapascal should be less than yield stress. So and yield stress we have taken from the property table is 345 megapascal. So it means that your critical load is the maximum allowable critical load is okay, and it should be 272 kilonewton. And this was all about this problem 13-13. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.